Today we'll be working on chapter 2, variable and operators. In fact, the previous few weeks, we work on several things. In the previous few weeks, we work on quite many things. Okay, these different things. These just help you to warm up for Java. Now we are officially on this Think Java curriculum to study it. So we will go through this, and before August, we will try to finish this course. Okay, it takes about half a year to finish that. So first thing is variable. So what is available? Variable is like when we say integer x, y, this is available. It's the same as your variable in math. So you can do like x equals 3, y equals 4, something like that. This actually is a variable. And variable name, you usually start with lowercase. And if they are two words, you can say this is like student. And then number, the N will be capital and then number. So the first leading letter is lowercase. Second one is uppercase. But this is only a convention. This is, if you don't follow it, you do compilation, you will still pass. But if you most of people would do this, that's a convention. Okay, so now to declare a variable, one of the most powerful features of a programming language is the ability to define and manipulate a variable. So a variable is something you can store your message or store your data in there. So, and in AP level, in Java, in AP level, we actually need to learn integer, need to learn double. Double is for real number. Int data type is for integer. And then we have Boolean. Boolean variable is for true or false. True or false. And then character is for character A, B, single character, and then string. String is what?
Do you want me to write those down in my notebook?
Yes, write this down in your notebook. Yeah. String is a So first one is starting from here, integer double Boolean character. Integer is for numbers 1, 2, 3, 4. 0, -1, -2. Those are integer number. Double is for real number. That's like 1.1, 0.5, 0.0, those kind of thing. And then it's Boolean. B-O-O-L-E-A-N, Boolean variable, that's for true and false, yes or no question. And then character is for single letter. And then string is for welcome, those are messages.
So the CHCR?
CHAR, character.
You didn't pronounce all of it, right?
I didn't pronounce, no.
Oh, you didn't spell all of it.
No, it's just this. CHAR, just this.
Oh, just that.
Yeah. You can also call it char or something. Some people pronounce it char, but I would say character. So here you see, here actually is actually a character here. On this corner is a character.
String is what? Well?
Welcome or something. It's just a message. Okay. So basically, you have that is available. So Now here we have the integer type. We have the integer type, right? We have the character type, like you can store characters. Integer, you can store integers, right? That's different type of variable. You can store data, and some type you can with some type begin with lower character and some lower case. I mean some type with capital letter, some with lowercase. Okay, now let's move on. Okay, usually if it starts with lowercase, the type with lowercase like integer or double, or this character char char, these are called primitive data type. So they actually just store some data like 5 and then assign to some integer. And some start with capital letter like string. String is S, capital letter string. That actually is considered as a reference data type. Okay, it actually just stores some pointer, some address, and then go to a certain object and store over there. Okay, so these two types are different. One is primitive type, the other one is a reference type. So let me show you what's the difference over here. So if you go to Google and you type Java data type, you will clearly see this. You have a numerical type. So you have this integer long byte, double flow, that's a 14 point, that's numeric. And you have character and Boolean. This character actually is char, Boolean is boolean. This we all call it as a primitive data type. That means you have a storage of the data like 525, and you will assign directly to a variable integer type. Okay, so in the memory you store this, and you directly send it to A. Now for a string is not primitive data type. You have a string A equals welcome to Java. Then you will store this welcome to Java to a certain memory location, and then keep the address of that and store in the A variable. That's only keeping the address, like 5522. I store the address of this, but not storing the data. This we call a reference data type. The reason why we need to do it this way is that because string, we never know how long it is. A string can be 1 character, can be 10 character, can be 100 character. So it's not a fixed size. And the primitive data type are fixed size. For example, you have an integer that's actually, usually that is only 32-bit. Double is actually 64-bit, right? But for string, it's not fixed size. You can put like welcome to Java and I love programming. So actually it can be very long. Since it is very long, you can no longer reserve it a certain memory space for it, and then you can find it. No, it's just find the address and store it into the variable string A, and that variable only store the data over there. So that's called non-primitive data type, or the reference data type. Is this okay?
Yeah, wait, let me write it down.
So the most important thing, you must know about the difference of the primitive data type and non-primitive data type. Non-primitive data type also called reference data type. This one is welcome to Java and I love programming. Okay, it's just a long message, long collection of characters. And you know it's not fixed length. You can add a lot of things into there. So you don't know how long it is. So you just put a certain location in the memory and then not assigning the whole thing to a variable. You assign only the address to a variable. And then you actually later can program the string to make it longer or shorter. Okay? That's why the integer is fixed size, only 32-bit. We know it's 4 bytes. The double we know is 64-bit. It's a fixed size you store in the memory of the same size. It never change. But string can be longer, can be shorter. You know, it can be welcome to Java. It can be welcome. It can be I love programming. It can be welcome to Java and I love programming. So string have never been of the same length. So it need to be non-primitive. So the other two data types shown here, like array and user-defined class, these all three are not fixed lengths. They have different, it's flexible. It actually will grow, will shrink. You never know how long it is. So that's called primitive data type. Okay. Now let's go back to chapter 2 now. So here we have the, so basically primitive data type is starting with lowercase, but string actually start with capital case. Okay, so now you can define a variable called name X and then string first name, last name in hour and minutes. So actually you probably used that before. We already know this. Okay, so those keywords, those words are, we call it variable. Now I still open a new program for this. So here, let's try a program. Let me call it variables. Okay. For the variables, I open a class, remove garbages, and then I type public static void main. Later I'll send this file to you, okay, of the class. Now, as before, I can type integer a equals 3, integer b equals 4, double c equals 5, right? And then integer d equals a times a plus b times b, right? These are variables, and we can have string. String need to start with S, capital S, and then you say, welcome to Java, and I love programming. So these are variables. And variable, as we said, as I said before, you can actually, let me see, something wrong. This one is wrong. You need to end with a semicolon. So semicolon is the end of a statement. Let me see. What is still wrong here? Check. Oh, actually, let me see. Oh, A already defined, so I changed name to X, whatever. Okay, so each one of these, we call it a statement. So a base statement is a basic unit for a program. So you have totally 5 statements. So each statement, I assign some value to a variable. Okay, so the right-hand side is value. So the right-hand side is value. Left-hand side is variable. So variable equals value. And this equals means assign. So assign the value to the variable. It's just like x equals 3 in math. So you have right-hand side value, left-hand side variable, and then you do assignment. Is that okay? But the assignment is by that equal sign. So right here we can have int I equals 0, and then I equals I plus 1. Okay. So this one is not really checking the equality. No. This equal sign is not checking equality. It's not checking, okay, I equal I or not. No, it's not actually doing this. This equal sign actually is called assign. Assign what? I assign i's value plus 1 to I. That equal sign actually means this. I assign this to this. So I equals I plus 1 means I increased by 1.
I increase.
Increased. I-N-C-R-E-A-S-E-D. Increased. I equals I plus 1 means that I have the I original is 0, now plus 1 is become 1, and I assign the 1 to the new i's value. So if I equals 2, then I plus 1 is 3, that assigned to I, so the new I becomes 3. If I equals 2. Okay, so equal sign actually is for assignment. You set a value to the left-hand side. Right-hand side is value. You get the data's value, calculating it, sum them, multiply them, or do division for them. Whatever, you will come up with the value, then you assign to the left-hand side variable. Is that okay? And every one of these, we call it a statement. Okay? Every one of these, we call it a statement. So right here, we have the first type of statement. It's called declaration of variable. So this one is called a declaration. So I declare A is an integer and that hold a value of 3. B is another integer that hold a value of 4 there. C is another variable that hold a value of 5.0 there for C. Okay, and then D is a squared plus B squared. Right? And X got assigned a long message. So X is actually the kind of variable I talk about. It's actually called reference. So for read reference, we can assign so many characters to a variable. So that variable X actually only holding the address like A35. That address pointing to a big chunk of memory. That big chunk of memory you put welcome to Java and I love programming over there. Another variable like A, it will store like 3 over there. It won't go to another place to find its data, but X do. X need that address to find its data. Is that okay? So int double. When the data type is lowercase, starting with lowercase, those are primitive data type. And for primitive data type, you will store data right away. For string, for array, for something else, you actually need to find a memory location for it and store the data over there. You need to, it's just like somebody send a package for you, right? And then if it's only an envelope, the mailman will just put into your post box, right? Your mailbox. But if it is too big, if the present is too big or the stuff some people send you is too big, they give you a notice. You got notice, and you go to post office to get it. Is that okay? That's how the reference work. You see the difference? For the variable like A, it only stores simple 3 over there. It's just someone send you an envelope and you can get that data right away from there. But if it is actually like a message like welcome to Java and I love programming, if I don't do programming a day, I will feel very sad. This message can be too long and then you don't know how long it is. So that actually address 5835 is some sort of an address, and you bring that address to post office to get your parcel or your package, or someone send you a box, right? That's indirect addressing, indirect finding the data. So that type is called reference type, and string is the first type for the reference type. Now let's move lower. So you have that, and then this declaration. And the end of a statement, we use semicolon. So it's just like a period. For each statement, we have a semicolon. That's like a period. Okay, and then variable name usually begin with lowercase later, in contrast to hello. Hello is a class. So the class, we usually start with uppercase. So for here, my class is called variable. So variable is actually capital case. And the variable A, B, C, D, E actually start with lowercase. And this only is a convention. Okay, this only a convention. If I actually declare some variable's name, that's not like A, B, C. If I declare integer good, right, equals 100, this is actually legal. This is legal, but actually it's not our convention. And these name convention actually vary from language to language. Okay, every language has different name, a different way of doing the ID design, ID names. So variable name usually start with lowercase later, and then in contrast to the class name, let's start with uppercase later. And variable name contain more than one word, then the second one will start with uppercase, the capital case. And the variable name can be case sensitive. So first big N name and first lowercase name are considered different things. So you use the name you want to for a variable, but they are 50 reserved words. These 50 words you cannot use for variable. So here are public static void. These are variable name. These are actually reserved words. So you cannot do this. You cannot do like, okay, I want a double, and then static equals 3. Okay. This one will create trouble. It is not allowed. So these words, about 50 of them in Java, is called reserved word. That's reserved for certain purpose, or you can call it as keyword. It reserved for certain purpose. And if you want to find a whole list for keyword, you just click this one. And here, Oracle give you all the keyword for Java. Okay, so we can go back. Now assign value to variable. So you can assign hello to message, assign 11 to hour, 59 for minutes. So this example shows 3 assignments. The comments illustrate the different ways of people sometimes talk about assignment statements. So equal sign doesn't mean equal in Java. It means assignment. You get some value from the right-hand side, assign it to the left-hand side variable. Okay. The vocabulary can be confusing here, but the idea is straightforward. When you declare a variable, you create a name storage location. That actually means when you say integer, A, this one is a declaration. It's called a declaration, declare a variable. Okay. But after doing that, you actually assign A and the memory location. There's no value. But later you can say A equals 3. Then you put a 3 on here in this memory location. But you can also do this. You can also do integer A equals 4. That's allow. That's one sentence, but finish declaration and finish assignment. So you can declare and then assign, or you can declare and assign at the same time. Both are legal. Both are legal statement for Java language. And then when you make an assignment to a variable, you update the value, okay? So as a general rule, a variable have to have the same type as the value you assign to. What this means actually, what this really means is actually I can have integer 3, a equals 3, right? But if I say integer a equals 5.0, no, this is wrong. Okay, this is totally wrong. This is not allowed in Java because the right-hand side is a floating type variable. It's a real number. So in my program right here, if right here I say a is an integer 3, and then a assign 38.32, and then compile it is not accepted because left hand side is an integer, right hand side is a double or real value on the right hand side. So two are of different type. Okay, now if I really want to assign this 38 to a, what can I do? You can actually put a int, convert it to integer. So for this conversion, you will actually have 38.32. You will actually trunk these two fractional part and assign 38 to integer a. So that's printed. Okay, that's printed in our Java program to see. So here, this one is okay, but if we print it, if we print a, right here, compile, and then actually right here, I run it. You see, it's only printing 38. It's not 38 point something. Right? But actually a truncation. But if I want to have like run-off rule, how can I do it? Say I have 37.65, and I want to assign to B, and I want the number to become 38. That is run-off, right? That's called run-off. The previous one put an int, that is called truncation. This one I want to do a run-off. For run-off, I need to do math.run, and then parentheses, and put a number inside there. And after that, now I system.out.print line, I put B in there. Let me see, low C, we go. So here I put int. Okay, and run. Wait, oh, I put it in there, sorry. I shouldn't put it in there. So let me see. I should put a long there. No, it shouldn't be this. Wait. Let me see, let me try again. Okay, the problem is not here. It's actually here. I should put it in over there. Wait, what's that? Wait, how comes I cannot get my file? Yeah, this one. Now I wrong. So the data is 38 now, okay? So this time you put now, those are old data. This time is actually 38 now. Now, let me put the system, because you may be confusing. So let me put this system.out.print and put a \f in there. Still remember what is \f?
Yeah, it's the
Clean up the whole page, right? So that's useful. Now that's wrong. So now 2 are 38, right? So previous one, actually, it will convert the 37.65 to a long data type. It's actually wrong to long data type. And then long data type, I need to convert it to integer. But both long and integer are integer type. And then actually, this one converted to 38. This is wrong off. And if you don't put the messed up wrong, it will be truncation. You cut whatever left over there. So for example, if I do C equals, say, integer 38.65, right? And system.out.print line, C, it will be truncated, still 38. C is what? Why 38.0? Oh, C is a double type. Sorry, let me change it to integer. So data pi actually is a real number. And then this one still be 38. So actually is not wrong off. It's for putting the in front of it, it actually is a truncation. It's not wrong off. So these are the detailed grammars, okay? So the message you can put this in there, but for a string type, you cannot put 1, 2, 3 to it. No, this is not legal because a double quote inside the two double quote and they put something in there. These are called a text message. So you actually need to put letters in there. You cannot assign a number for it. A number without double quote is a number. A number, you put a double quote in front of it and the end of it is called message. So it actually are characters. It's actually are letters, text, not numbers. So here we declare a message is a hello, and this hello is a message. And integer hour 11 minutes 59. So here is the memory diagram. Because Java uses the double equal sign for assignment, not for equality check. So it attempts to interpret the statement A becomes B. So this equal actually means becomes or assign something to A. So this one A assigned with 5 and B assigned with A. So now B and A both are 5, and then I assign 3 to A, right? So when I assign 3 to A, what is the B value over here? After this 3 statement, what is the value for B? You assign 5 to A, and then you assign A to B, and then you assign 3 to A. What is the B value after these 3 statements? It is 5 or 3? Which one?
so B will be 3.
B will be 3? No, this one B is 5. The assignment is like I get the value 5
Oh,
to
first?
A.
Oh, okay.
Okay, so this is different from math. For math, you say like, okay, x equals y. For math, you say x equals y, right? And x equals 3. So y equals 3. No, this is math. This is not Java. Java means A assigns 3 with it. B equals A means B, I assign A's value 3 to B, and then A changed to 5. So 1, 2, 3, after 3 statement, A is 5, B is 3. It's different from this. That's mess. It's not Java. Okay, so always consider that equal sign as assignment, or I say becomes. So A becomes 5, B becomes A's value, and then A becomes 3. So that's the variable memory diagram. And for this class, it's a state. So this is called memory diagram. Okay, printing variables, then you can print out a string, print out a variable. That we do this many times, so it's fine for us. The next one, arithmetic operator. As arithmetic operator, I actually mentioned this before. We have plus sign, minus sign, multiplication sign, slash for division. And what's this for? Percentage sign, what's this for?
Which one?
The last one, percentage sign.
Percentage sign is like
like 5 take percentage sign with 3. What's that? What does this mean?
5 divided by 3.
No. I told you its division is 5/3. That's division. 5 percentage sign with 3 is called modular.
To get a reminder.
Yeah, to get a remainder.
Mm.
Okay, so you definitely need to study more, okay? Otherwise you will forget. You know, this Java is more than math. It's take more time than mathematical courses. Mathematical courses, you just remember what? You just remember the basic concept and grammar, and you'll be able to do something. But Java or any programming class, it's like more like a language course, like Spanish or like Chinese or like English. You need to speak over and over. You still make grammatical error. You still make pronunciation error. You still make a lot of different errors, right? So for programming, you have to not only study hard, but also spend more time to make sure that it becomes your language. Is that okay?
Okay.
So here we have 5% 5 operator, plus, minus, time, slash, division, and percentage. Okay, these are operators. So out of these 5, who will operate first? And which 2 will operate later? Say if I have A plus 5, I'm sorry, I have A plus 5 modular 3 times 2. What would be the result here? A plus 5 10 modular by 3 divided by 2. What would be a result here? Listen. A plus 5 modular 2, modular 3 and time 2. What would be the value here? Okay, I write again. We have A plus 5 10 modular by 3 times 2, right? I have time 2. Then what will be the value here? Which one? There are 3 operators. Which one will do first?
5% 3.
5 10 modulus by 3, right? So what's the result here?
Result will be 2.
2. And then which one next?
Times 2.
So times 2. And what's the result here?
4.
Okay, the answer is 12, right? That's the correct answer. So percentage and multiply of the same priority, but left side go first. We scan from this way to this way. So left side go first. Even though percentage sign and multiplication and division, they are of the same level, you do the one on the left first. Next one, you have 10 times 2, and then divided by 3 times 4, then plus 5 take modular by 3. And then what's the result here?
So it's 10 times 2 first.
Mm-hmm.
No, 3 times 4 first.
Yeah, what's this? This is 12. Okay, next. What's next?
10 times 2.
That's 20. Okay, here. And then 20 divided by 12.
And 5 percentage of 3.
And that's actually 2. And then what's the next?
So that would be 1 point. That'd be 1.
1 or 1 point something. Which one?
1.
Why?
Because there's no decimal places.
Yeah, this one is integer division. I told you before. This is called integer division. So integer division, you only take quotient. You don't take remainder stuff, okay? And then plus 2, you get 3, okay? The answer is 3. Okay, that's about it. Let me see. Okay, and the next one is 14-point number. 14-point number is actually called real number in math, right? So you can use float or double, but float is 32-bit, double is 64-bit. But in high school, you only need to use double. Float is only 32-bit, and double is actually 64-bit. Okay, this one is the 4 byte. And this one actually is 8 bytes. And to keep good precision, high school AP computer science course only use this. This one not tested in AP. The top one won't be tested in AP. And this is called what? This is called real number or double value number or 14-point number. So we have these 59. Okay, now here is a question. For double value, if I have 3.2 divided by 1.6, what would be the result?
2.0.
Yeah, this one is 2.0. Okay, this one is no longer integer division. This one is 14-point division now. If one of the data is float type or double type, you will do the real division, not integer division. Say if I have like 2.0, here I have 15.2. What will be the result?
7.6.
7 point what?
6.
51.
51.
Yeah, you times 2. Let me see. Okay, 6. 7.6, yeah. Okay. So this one is actually double type. Okay, and then there's a result comparison. So if you assign, as I said, if you assign a double data type to the variable integer, it will be wrong. What you need to do is that if you really want to truncate the result, you actually need to do is assign an integer before a double value, before you assign to a integer. Is that okay if you need that? But if you assign double value with 1, that's fine. That's legal. But you actually, usually we want you to write 1.0, but it can be 1, that's actually legal, but it say that it's a big style. Okay? Now I bring up. Now I will bring up my note for my AP course. I will bring up the slides. I bring up the chapter 2. Okay, remember this page. Over here, we have this chart, right? So if I convert an integer to a double type, I'm sorry. If I convert an integer to a data type, this way to this way, that's fine. So I have, actually I have a double a equals 3. This is fine because I'm converting the integer to double. But this way, no way, this one is wrong. So if I have integer b equals 4.0, this one's wrong because you're trying to convert this way.
M
Okay.
B or integer B?
Integer b.
Oh. Okay.
So this is called implicit type casting. Implicit that I don't need to do anything. But if you want to make it work, you need to put int and then parentheses before the 4.0. Then that would be fine. This one is fine. But if you put integer b equal 4.0, that's wrong. Actually, you're trying to convert from right to left. Okay? Is that okay? So this chart you need to remember, okay? From smaller 8-bit to 16-bit, okay, 16-bit to back to 8-bit, no, it's wrong. From 16-bit to integer, 32-bit, that's fine. But from integer to short, no, that's wrong. Okay? From integer to long, okay, but long to integer, no. That's so on the right hand side is higher precision, left hand side is less precision.
How do you tell that which side are you going to?
Well, you remember the name. You have to know which one is higher bit. Byte is 1 byte, 8-bit. Short is 16-bit. Int is 32-bit. Long is 64-bit. And these are integers. And then float and double are floating-point number or real number.
How do you know that he was going from long to float?
Long to float? Long to float. Okay, if you just write, I'm sorry. That actually is a good question. Wait, I lost my page. One moment. If I write a 5.0, without telling anybody what type it is, it will be double.
5.0?
Yeah, if I just write 5.0 without telling anybody else.
That's 5.2.
Yeah, I'm sorry, 5.2, yeah. It actually is double type. If I say 3, it will be integer type.
Yeah.
But if I say byte equals 3, then this byte actually will be, let me clear this. If I write something like byte a equals 3, then this a is actually a bit. It will be a byte. And then I say long C equals 5, then this C will be long type, 64-bit. So if I have a C assigned to integer X, that one is wrong. That's not allowed because you are trying to convert from a longer integer to a short integer. Is that okay? But if you got just a number without telling anybody else, integer is integer type. Floating point is double type.
Can you do from double to long because they have a same beat?
Double to long? No, because this is real number. Real number, it means that you have 5.3355 something. But long is an integer. You will lose this. Got it?
Okay.
So these two actually higher priority. You cannot convert it to this way. But from this way to this way, it's okay. It's upward conversion. You gain precision. So this side are integer, not 4, 5 type integer. These two are actually real number, and real number actually has higher precision usually. So converting from the left side to right side is not allowed. Right side to left side is okay. Okay. So this is called casting, implicit type casting. Now let's go back to the class, the Sync Java textbook. So we start this Sync Java project course one by one, and later I may add some programming example in the course, not just limited to Sync Java, but we are trying to finish this Sync Java first, okay, before we move on to the AP course. Now the next one is rounding error. Rounding error, say we have the 0.1 times 1 times 10. Suppose it should be 1.0. But sometimes the result can be 0.99999 something, because it's actually the double overflow type actually will create some rounding error because it's only 64-bit. It's not really 2,000-bit or 3,000-bit. So sometimes, usually, it would have still have some round-off problem. For example, like I assign a value called pi. I assign a value called pi to actually a double pi, say. And this pi is like 3 point something, right? You will lose some digit and then assign to this pi. It won't be the pi value to 2 million digit. No, it won't be like something like that. Because in real computer, we still need to truncate it to fit a 64-bit format. Okay? So this is a round-off problem. This one is called round-off problem. So sometimes you try to do this. Sometimes you try to do this double x equal 2.0, and then double y equals 0.5 plus 0.5 plus 0.5 plus 0.5, right? And then say if x equals 2 equal sign means equality check. 2 equal signs mean equality check. Equals y, then system.out.print yes, say, right? If these two are equal, I print yes. Else, I have system.out.print and then print out no. For this one, you may see a no. You know why? Because this one you plus 4, you may lose some bit over there. In the computer, it's not really stored exactly 0.5. You may lose some bit. And then when you compare to 2.0, it may not be exactly the same. So that kind of effect, we call it a round-off error. Because you need to keep a certain amount of bits, so you will have the round-off error. And round-off error, we usually will create what? When you see a picture or see a movie, round-off error usually will create what? See a picture, and a person should be sharp, right? Like this, right? But you may see something like this at the corner, right? That actually is called the mosaic effect. That's caused by this round-off error. So let's bring up the browser. Something like this, not exactly sharp. Okay, runoff somewhere is called mosaic effect. And not, analog you cannot see, but digital usually have this runoff problem. A color may not be exactly the color you take the picture, and something like that. That's called mosaic, and mosaic effect actually caused by runoff. Runoff is one of the reasons for mosaic effect, but not all. So if you actually here, if you search for runoff effect for audio, okay, it will create some audio effect loss. Let me use an image. Then it will actually show you some quantization error. If you really analyze the data, there are some effect you will see. Okay. Now let's go back to textbook. Operator for string. Okay, so they are operator for string. We see this plus sign before. It will actually will concatenate it together. But if you do multiplication, division, or minus, it won't work. String, you cannot, like text, you cannot do multiplication, you cannot do minus, you cannot do slash, okay? Only plus sign is okay. Plus sign means connecting two words together, two sentences together. But if you put a number 1, 2 before hello, now 1 or 2 will be converted to what? To a string. But remember, before we see it, this one was print 3 and then hello. The second one was print hello and then plus hello and then actually 1, 2. The second thing, because the first one you plus 1 plus 2 first, and then you see a string, and it actually will combine, become 3 hello. The next one you see a hello and combine with 1 first, so it actually is a hello 1, and then you see a 2, and then put it as here. Is that okay?
Okay.
So let me clean this. So this chart here, actually there's a 1, actually 1 behind double. That one is actually called string. So you have like double quote hello plus 3.0. Then you will become hello 30. When you print out, it will become something like this. Okay? But if you put something like 1 plus 1 plus 1 plus 8, it will become 1 plus 1, 2, 2 plus 1, 3. So 3, 8, it will become 3, 8 eventually. So we scan from left to right and work on the operation first before you sum up with the last one. But if you have the hello first and then 3.0, it already has a string. String is stronger than double, stronger than float, stronger than long. So everything will be converted to string if string go first. Is that okay? So now I give you a test. If I have parenthesis 1 plus 2 plus A, and I have A plus 1 plus 4, then what the first one will print out? That's what is the second one will print out?
3A for first one.
Yes. Second one?
A5.
Second one is A5, yes. The parenthesis has a higher priority than string. So here is like string and then actually parenthesis is even higher. Is that okay? So, computer is very complicated. It's not just, I want to make it work and it will work right away. If you miss somewhere, you will end up with some result you don't like. So there is a so-called order of operations. Okay, you need to learn the order. So if you really want to know the whole order of operations. Here in your class, you had a reference. You just click these operators, and it will show you the exact order for all of the operators, which one will come first. So yeah, and then you check, okay? You check here. Just in here, you will see the, I'm sorry. You see that the order of the precedence. Compiler error message. Okay, if it went wrong, it will print some error messages. That's actually wrong. Okay. Okay, and if you miss this, if I delete this, it will show you an error missing the percentage. This actually is called error message. Okay. And then I think this is fine. Another type of error you have, this one you have compiler error, you have runtime error. Another one is a logic error. We totally have 3 types of error. Okay. Now let me tell you what these are. There are 3 types of error. First type is grammatical error, or we call it syntactic error. Is also a syntax error, and also called compile time error. I'm sorry. Okay. For example, like integer a equals 5.0. This one will complain, and that is called a compile time error. So to see this, it's easy. You come to here, and then I just delete this semicolon. It create a compile time error. When you hit compile, it create an error. So I need to put my semicolon there. So this one is called compile error. Second type of error is like I have integer, which is a equal, x and g equals 10 divided by 0. Okay, this one grammatically is correct. I compiled it, no problem, it passed. But if I run it, I see a red ink. Okay, division by 0. This one is called a runtime error. When I run it, it becomes an error. Because from the syntax point of view, it's actually perfect. It's the right one. From syntax point of view, it's actually the right one. So something like this, if I have an integer, a equals 10 divided by 0, this division by 0 is called a runtime error. You can only see that error when you run it, not compile it. So right here, I hit the compile, no problem. It says compile, class compile, no syntax error. Okay, but if I really run it, I will actually see the error. I'll see the error over there. That's called runtime error. So the next one, the third one is called logic error.
Wait, I thought there's only 3.
Yeah, we have 3: compile error, runtime error, and logic error.
How about the first one, the syntactic error?
That's a compile error.
Oh.
That you use the wrong syntax, right? The last one is logic error. Let me show you what logic error is. Logic error means like the program will run perfectly, but actually the result is wrong. Say if like integer score equals say 90, right? And last time I told you this, if the score greater than 60, greater than equal than 60, then I say let me see, right here I have a string grade, and right here I say grade equals D string, right? And then else if I copy this over, and then this one I greater than 70, and I will say this one is a C, right? If I continue doing this, if I continue to do this, okay, last one I'll say grade is F, you gotta fail, right? And if this one greater than 90, I'll say this one is A, right? Greater than 80, I'll say is a B, right? Okay, and then later I actually system.out print line, and I print my grade. I print my grade over here. Okay, now I compile. And let me run it. I have 90, but my grade is assigned with D. Wait, something wrong. What is the problem here? So logic error is you compile correctly, you run, it also wrong, right? But it still get the wrong error. So that's three type of error is the first time, the compile time, you got an error, we call it what? Compile time error or syntax error, right?
Yeah.
And it pass, go through and it wrong, but it create error that called runtime error. Third type, he also pass and then but not expected. That we call it logic error. So draw down this chart.
So it's like the thing that you wrote wrong, right?
Yeah, the way I wrote is wrong. So copy to this chart first. First you copy this logic error. Logic, L-O-G-I-C.
Okay.
Logic. I write too quick, okay? So first you compile, it fail, you call it compile or syntactic error. Second, you run, but you will have runtime error. Third one, not expected, not as you expected, we call it logic error. Okay?
Okay.
And then how to fix it? For this one, how to fix it?
You just fix your program.
What?
You just fix your...
How can I fix it here? How can I fix it here?
You change the...
The answer is I change this 90, 80, 70, 60. And I change the grade here to be A. This one to be B. This one C, this one D. And this time I run. Now I got an A. Right? I got an A. So if I change it to say 78, right? And compile and run, I got a C. So this is correct. You think about it, why this version works and the other way around doesn't, okay? You think about it, okay? You think about it. And then we are the end of the chapter 2. You know, the later chapter I may move slower, but this one we finish chapter 2. So you work on 1.3, and this here you work on 2.1 and 2.2 for this week. The chapter 1 exercise 3.
Wait. And
chapter 1 exercise 3. Chapter 2 exercise 1 and 2.
Okay.
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 Okay. Any question for today?
No.
Oh, good. And you need to spend more time on this, right? Okay. Bye now.